Hello, a very good afternoon to you, our valued guests. Welcome to the Singapore Polytechnic Engineering Showcase Webinar 2022, a virtual showcase of projects and demonstrations put together by the SP Engineering Show Committee. I'm Kei Chiang.
And I'm Rijo. We'll be your host for this event today.
In this webinar, we will be presenting a wide range of innovative industry projects, which are the hard work of our final year's students. These student-led innovations and industry projects are specially developed and curated based on real industrial problem statements through the use of creative engineering efforts. So stay tuned to find out more about the different project domains covering 5G, artificial intelligence of things, in short, AIoT, robotics, autonomous vehicles, and green environment. Without further ado, let me start off with the project showcase segments for today's program. There are altogether 6 projects that will be shown to you. The presentation will begin with a project introduction video, followed by a sharing sessions by the project students. You could text your questions in the Zoom question and answer tab.
Before we start, we would like to share that there will be 2 short quizzes, one midway and the other at the end of today's program. Prizes will be awarded to the first 2 submissions with the correct answers for each quiz session. So stay tuned. The questions related to the projects will be presented to you during the quiz time.
The first project lined up for you is titled Zero Energy Wellness Garden. The student presenters are Muhammad Irfan bin Muhammad Shanif and Yap Jin Lin. Let us watch the project video now.
There's something about the presence of gardens in our life that brightens our day. Gardens offer beauty and freshness to our urban surrounding, boost our mood, and help us to relax and reduce our stress level. Gardens can provide not just beautiful flowers, but also nutritious veggies for our eating pleasure. Enjoying gardens and its benefit need not have to entail trips to many of our parks and gardens. In fact, you could create a net zero wellness gardens with smart technology in your very own home. Here is the prototype of the wellness garden.
What is so special about the garden? Well, it has several innovations that we believe makes it so far a unique garden in Singapore. Firstly, its energy system can harness natural sunlight to generate electricity and vegetable growth. Hence, it is able to achieve net zero energy from the power grid of our greenhouse vertical farming system. We can grow 140 plants with 14 watts of electrical power, and this power is harnessed solely from solar panels.
Secondly, it has an IoT system which can measure, display, and save all important data for optimal plant growth, such as water temperature, pH, EC, etc. in real time reliably.
Thirdly, the greenhouse has a new roof design with flexible lightweight solar panels and transparent strong polycarbonate sheets with UV protection. Furthermore, the gaps in between the panels can be adjusted to offer varying amounts of lighting. It also has a solar-powered air circulation system for ventilation and cooling inside the greenhouse.
Fourthly, its hydroponic system has an exit filter and bubble generator added to the water tank to prevent water blockage and mosquito breeding inside the tank. Both methods are currently not seen in the market.
It will directly benefit the local farming industry and ultimately everyone in Singapore. More importantly, it is in line with our national goal to produce 30% of our nutritional needs locally by 2030. This project is under an ongoing collaboration with our local industrial partners, Applied Scientific Technology Private Limited and Green Valley Farms Organic Private Limited.
We thank the team for the wonderful project videos. Allow me to start off with the first questions. Can the team share with us what does your project aims to do?
Well, to answer that question, first we have to give you a bit of context. Currently, Singapore only uses 1% of its land for agriculture. Singapore aims to produce 30% of its fruit locally by 2030, up from 10% we currently have today. SG Green Plan foresees a future where we all move towards using solar. But there's major problems with that. For example, Where do we put our solar PV and where do we grow our crops? Well, our project aims to provide a solution for that. We plan to make it better for growth of plant, more efficient, effective, and more productive.
Oh, so you mentioned about the wellness garden. I heard it's pretty unique in Singapore. So could you tell us what makes it so special?
Well, it is very unique indeed. Within a 1.5 square floor area and a 2 meters high, we can grow upwards of 140 plants. By harnessing the solar panels that we have on our wellness garden, we can operate our garden without any consumption of electricity from our power grid. This is why our project is called Zero Energy. Comparatively to soil-based traditional farming, our system uses 90% less water, land, and 99% less water.
That's a very efficient way of growing plant. Now, for the practical aspect, whom does the project benefit?
Well, it benefits Singapore as a whole, but if you want to be more specific, it benefits urban farmers and citizens who are keen on farming. If our project were to go global, it will not only, we believe it will not only help Singapore's economy growth, but also helps improve the cost of our fruits and vegetable stores. It will also give us the options of safest and freshest option available in the market.
Okay, thank you. So you must have faced many challenges during the project. So could you share with us some of the challenges that you have faced?
Yes, indeed, we faced some challenges during this internship program. As you recall from the video, we're all from an engineering diploma. Therefore, we have no gardening and farming background. So it's more of a step in the dark and try and error. I could recall an incident that happened where due to a blockage in the pipe and the environment, the water in the system dried up and we lost half of our plant. Due to that, we tried to implement a water flow sensor to the system, which detects water flow and also informs us if there's any error in the system. As my partner said just now, we're able to produce 140 plants, and we're quite proud of how versatile our greenhouse is. On the other hand, we also had problems with the IoT system. First, we have to make sure it's user-friendly, but also synced up all our sensors and have a graphical user interface, a GUI, in the IoT system. But overall, we believe to overcome these challenges is just the willingness to learn new things and hard work.
I guess the team must be jumping with joy when you see your plant starts to grow. What is the next for the project?
Since this is still an ongoing project with our industry partners, we're still brainstorming a few more ideas right now. So to throw in a few, we're still planning to make an automation system for that top ups the water and nutrients in our system, which make it hassle-free for user if life were to go back to things before COVID. We also plan to make our greenhouse more energy efficient and sustainable by tapping into revenue of renewable energy such as hydropower and wind power. Not only that, we also believe that currently our GUI is just showing users just data. So we plan to make it more interactive by making sure that users understand what the data means and how to work around it. But ultimately, we want to make sure our product can be commercialized in our local and global market.
Many of us stay in a flat. Can we ask, can this project be implemented in my HDB flat?
I think it can. I think this is the aim of our project also. You can put it inside your house, but also you can put it in your corridors outside your flat or at the balconies of your house. But I think it's okay. Yeah.
You will go well, I hope.
Yeah.
Yeah, so just talking about plants, what type of vegetables is suitable for this project?
From what we've done, from our research we've done right now, we believe that any type of plants can be planted in our system, but there's a few prep for it. Like you need to make sure the pH and nutrient is optimal and the environment for the plant is optimal. Just do a few research on the internet, then I think there might be a few studies on it. But currently we're experimenting on kailan, kale, basil, tomatoes, and strawberries.
I think you guys make a good farmer in future. Thank you, Team 1, Zero Energy Wellness Garden, for the presentations and the reply.
The second project is titled Office Transporter. The student presenters are Renee Orzi and Hubert So Yong Tai. So now, let's watch the project video. You missed the third Zoom session.
As technology
Let me
becomes
show-
more advanced, autonomous robots will be used in a wider array of environments, from labs and research centers to future ground-based robots being utilized out in the streets and at home. Thus, we thought about how we can bring this technology into the office space by designing and creating an autonomous transporter for our partnership company to transport office documents in an indoor space with customized features.
The partnership company has requested to redesign the transporter to provide better efficiency and to comply with the safety standard ISO 13482 that inherits safe design and protective measures. An additional compartment was built to store confidential documents for authorized staff. Digital locks are also added for both compartments with a common code for non-confidential documents and a code for confidential documents. Both locks are capable of changing PIN code to cater for the different departments and usage.
Other safety features include an anti-collision sensor, which caters for human traffic, a fire-redundant material battery box to prevent hazards in the event of battery failure, non-contact switch that allows the vehicle to perform auto-charging and preventing accidental touching of live parts.
Considering the current pandemic, hygiene is one of the highest priorities for everyone, especially office workers. Hence, the transporter is designed with the capability to disinfect the office. An ultraviolet lamp is implemented on the transporter with the addition of 20% size reduction to 400 by 400 mm, which allows it to maneuver around the office perimeter effortlessly to disinfect and sterilize the office after working hours.
Since this project is a partnership project, the vehicle is customized to the client's needs. However, this project can also be beneficial to industry such as government agencies, law firms, healthcare, and airports with their own customizable features.
With all the sleepless nights that the team has been through, this project enables us to learn and embrace a variety of skills and challenges, ranging from mechanical, electrical and electronics to programming. With our newly found skill set in electrical troubleshooting, programming software in ROS and LabVIEW, 3D modeling and fabrication, we will be able to apply them in future engineering projects to help push the boundaries of innovations.
That was an interesting project video. May I ask this team, what's the objective of your project?
Thank you for the question. Our project's main objective was to redesign and pre-program an automated vehicle with our partnership company, ZIG Sensor Intelligence, a sensor manufacturing company. So our vehicle will be able to pick up and deliver documents upon remote request and also to your selected destination. So with our vehicle, it will help assist making admin processes more efficient and safe, especially when work from home arrangement gradually cease. Yeah.
The project looks very complex. Could you share with us what is the problem you face and what is the solution you arrive at?
Our partnership company ZIG has requested the vehicle to be more efficient by being able to maneuver around limited spaces. So since automated vehicle can be very dangerous if not designed and programmed properly, so ZIG has also requested us to comply safety standard ISO 13482, which it's a rule for making the vehicle safe and be to have those protective measurements. Yeah, so for our vehicle, we have like three main safety features. Firstly, it would be an anti-collision sensor to cater for human traffic. Secondly, it will be a fire redundant material battery box, which will prevent fire intensity in the event of any battery failure, and it also will help to prevent damaging the other components in the vehicle. And lastly, a non-contact safety switch, which will help the vehicle to auto charge by itself, and also to prevent accidental touching of live parts. So with these and also complying the safety standards, our vehicle will help to strengthen and reinforce the workplace safety, and also mitigate accidents to occur in workplace. And I will pass it to Hubert to talk more about the mechanical design.
Thank you, Renette. So as what Renette mentioned, allowing the vehicle to be smaller so that the vehicle can move around the office in limited spaces. So basically, we changed the physical size of the robot from 500 by 500 mm to 400 by 400 mm. However, with this size reduction, it also changed on how we drive the wheel, the placement of the motor, and the circuit boards as well. So in the previous version, the motors are placed linearly to one another. However, in our version, our motors are placed parallel. So instead of driven by gear, we use the wheel to be driven by gears instead. And I also remember that we had a problem choosing what type of gears to use, because the number of teeth also determine the diameter of the gear. So bigger the diameter, that means we have a smaller space from the ground to the base of the vehicle, therefore decreasing the suspension. And it might also affect our vehicle to go on top of bumps. And other than that, the circuit boards, instead of placing it horizontal, we place it vertical, because in our previous version, we already have limited space for cables. And now with even smaller space, some of our circuit boards have to be placed vertically to create extra space for cable chain to organize the cable. And by organizing the cable, in the event if we need to troubleshoot or any wire failure, we can just easily remove that wire and just replace it. And as for the circuit, and for the extra component that we built, it's not only for confidential documents, it's also to improve the delivering process of this robot. So instead of delivering from one location at a time, we can deliver to multiple locations. And let me emphasize that. So basically, for example, if let's say your boss office is at the same level as you, and basically this additional compartment is for confidential documents, right? So this robot, instead of only traveling for common stuff, it can travel to both your common stuff and your bosses also. And for our solution to hygiene, we implemented the ultraviolet lamp to sterilize the office after working hours, and to ensure that nobody's in the office while we are doing it.
Wow, so it seems like this project is quite versatile. It can help to transport equipment. So we are just wondering, who does the project benefit?
This project is most beneficial to Six Sensor Intelligence, since this robot is custom-made to their own needs. However, this project can also be beneficial to many industries with their own customizable features. This is what makes our project unique, because every robot that we make is based on the client's need. And with our robot, as long as with the ultraviolet lamp, is useful to many industries, such as healthcare and airport industry, especially with this current pandemic, because the ultraviolet lamp can be used to sterilize the wards and terminals as well.
Your project has many features and it covers quite a few technologies. Could you share with us what are the learning experience that you have for this project?
For me, I feel that our project has granted us insights on the working world, how the working world is like, and also providing us a platform to collaborate with a partnership company, and also be able to overcome our obstacles faced along the way. So for myself, I feel like I've learned new skills that are not taught in our syllabus. For example, using the water jet machine, and also using programming software such as ROS and LabVIEWs. So although along the way we have many setbacks, but I think this is what we will have to go through while doing projects, and this is part of our growth. Yeah, so I think I really learned a lot, and as a team, we also grew a lot. Yeah.
So thank you, William. So as a team, right? So basically during our final part of the project, we faced many challenges, ranging from mechanical, electrical to programming challenges. And personally, through all these new and difficult challenges, I've gained a plethora of experience, ranging to help my future career as a robotic engineer, and also my future study in university. So as experience such as electrical and mechanical troubleshooting has allowed me to change my perspective on the word broken. So broken, in my definition, is now something that can be fixed instead of something to be replaced or thrown away. And although having a background in design technology in my secondary school days, this project has enabled me to draw and create far more complex shapes and design using 3D modeling software such as Inventor. And through Inventor, I can view assembled product, I can draw any product I want and see on screen rather than creating the actual object itself.
When we are using your mobile robot, how long can a battery last?
Currently, our battery, what we have tested is using 4 LiPo batteries, which you have to only charge for like 4 hours to be able to use it for 6 hours. Yeah, so you can also decrease the charging, decrease the charging time by reducing the current use. So the maximum current we have used is like 25 amperes.
Wow, that sounds cool. So we are just wondering, what is the future plan for your project?
For the future plan of this project, we can upgrade the software as during our testing, the software that we use, apparently it kept crashing, sometimes hang also, and sometimes it can be quite laggy. So the current program that we use is ROS1. There's also a newer program called ROS2. It's also because while we are testing the robot, sometimes our robot move, but then the data on our screen is a bit laggy, whereas ROS2 can show real-time data. And also ROS2 is easier to port over to another project. And yeah, ROS2 is just a lot more reliable than the current firmware that we are using. And also, I was thinking of maybe we can tweak some areas in our robot, like for example, the suspension. So we can modify the suspension a bit so that we can let the robot go on bumps smoothly. Also, this application can be implemented on bigger robots, such as our current project, AGV, our automated guided vehicle, to not only carry documents, it can carry a lot more heavier loads.
It's good to hear that there's some expandability to this project. So thank you, Team 2, Office Transporter, for the presentation and replies.
The third project is titled Green Construction Materials. The student presenters are Tan Ting Chong and Li Ping Hang. Let us watch a video now.
The Sustainable Concrete project is about replacing the natural coarse aggregate and sand with domestic and construction waste such as plastic, recycled coarse aggregate or RCA, and washed copper slag, WCS, to produce concrete. The heavy reliance of plastic products have made us forgotten how harmful it is to the environment when degrading one.
Sand is not a natural resource of Singapore. Therefore, it imports sand from the neighbouring countries. Our project aims to reduce waste going to our only remaining landfill by encouraging industry players in construction to recycle, upcycle, and to use sustainable construction materials in their projects. Thus, we have developed a green concrete for non-load-bearing structural elements like walkway slabs, partition walls, and common paths to reduce the negative impact on the environment. Initially, we experimented with different concrete design trial mixes. First, specific amounts of cement, coarse aggregates, sand, RCA, WCS, plastic and water are prepared. Next, dry materials are mixed thoroughly with water using a jump mixer. The mixed concrete will then be poured into a 100 by 100 mm cube molds in 3 equal layers. They are compacted 25 times with the compacting rod for each layer. The concrete is left to harden in the cube molds for 1 full day, placing them in the curing tank the following day. These cubes are to be tested in a machine for 7, 14, 21 and 28 days compressive strengths respectively. From our observation, concrete gains strength from 7 to 28 days in general. Concrete mixed with RCA and WCS achieved a higher 28th-day compressive strength as compared to concrete mixed with plastic material. We found that using plastic, RCA and WCS in the concrete is not only environmentally friendly, but is comparable in strength to conventional concrete. Through sustainable development, we can reduce both the impact on our limited landfill capacity and dependence on imported construction materials. Less waste is generated and some construction waste can be reused to produce concrete, reducing transport costs to transport construction waste out of the sites. Costs are further reduced as recycled materials are cheaper to obtain. Stakeholders in the construction sectors will benefit on multiple levels with this innovative material.
It is sure very interesting to see the team making bricks in the lab. I believe this is new to all of us. Can the team tell us what is the scope of this project?
To answer this question, the project is about replacing natural coarse aggregate and sand with domestic and construction waste, such as plastic, recycled coarse aggregate, and washed copper slag to produce the concrete. We are trying out different concrete trial mixes with the use of sustainable construction materials in order to obtain the highest load it can bear before it cracks. Our project is to develop a green concrete for constructing non-load-bearing structural elements like partition walls, walkway slabs, and non-load-bearing structural elements, common piles in Singapore and developing countries, so as to reduce the negative impact that will harm the environment.
After hearing the scope of your project, what is the problem that you are trying to solve?
So, sand is a significant ingredient in making concrete. So, sand is not a natural resource of Singapore, hence it is imported from neighboring countries. Our project aims to reduce the sand usage in concrete, so we thought, why not use waste materials? And the biggest waste material we hear about is plastic. So we aim to make use of it. So this project goes beyond recycling to upcycling, using the waste to make something more useful. Our aim is to encourage industry players in construction to upcycle and to use sustainable construction materials in their project whenever possible. This requires a mindset change of the industry to view every unit of waste as a potential resource during the building and construction process and the life cycle of the building.
I think it's not easy to come up with a new brick using recycled materials. Perhaps you can share with us what are the processes that get you into the solutions.
So firstly, we wanted to find out whether the amount of recycled materials used actually affects the compressive strength of the concrete. So hence, we experimented with 5 different concrete design mixers. So these mixers actually consist of specific amounts of cement, coarse aggregates, sand, and our recycled materials like RCA, which is recycled coarse aggregates, WCS, which is washed copper slags, and plastic. And then lastly, the water. And then, so each mix actually has different amounts of recycled materials used. So these materials will be prepared and are mixed thoroughly with the drum mixer. And then after it's mixed thoroughly, it will then be poured into a 100 by 100 millimeter cube mold in 3 equal layers. So each layer will actually be compacted 25 times with the compacting rod. And then after it's compacted, it will be left to harden in the cube mold for 1 full day before it is placed in the curing tank, which is basically a tank full of water. And then it will be taken out from the tank for every 7, 14, 21, and 28 days to test their compressive strength in the compressive machine. And after that, after the results are collected, the mix that achieves the highest compressive strength will actually be the optimum mix to use. Yeah.
So it seems like there are a lot of materials which go into making a brick. So how much recycled coarse aggregates and washed copper slugs can be used in concrete to give it the ideal mix?
So in theory, these cubes can actually be fully made with recycled materials. However, the construction industry tends to shy away from using materials made with recycled materials. So for this problem, we actually decided that the use of recycled coarse aggregates and washed copper slags shall be limited to a maximum of 10% replacement of mass of coarse and fine aggregates respectively. So by making sure that it's a maximum of 10% replacement, this also ensures that it complies with the requirements for the BCA Green Mark Award.
The team has mentioned some benefit of the new brick. Could we know what other benefits are there of using your green construction materials other than upscaling plastics?
So the other benefits are that it actually reduces cost by producing concrete, as obtaining these recycled materials is relatively cheaper than obtaining raw materials. So by using these recycled materials, it actually reduces costs, and furthermore, it actually reduces construction waste from construction sites, as some of these construction waste can actually be used to make this sustainable concrete. For example, during a demolition, the debris that is produced by the demolition can actually be used to form this sustainable concrete. And in turn, this also reduces the transport costs, as there will be lesser waste needed to transport out of the construction sites. So rental fees for trucks will be lesser also.
So now come to the cost itself. How much can be saved for using this construction material?
Okay, so if we follow with the replacement rate of 10% for the recycled materials to raw materials, so actually for experiment, we actually use 1 kg of cost aggregate. And then and if we were to factor in the 10% replacement rate, we will actually be using 100 grams of recycled cost aggregate for this project. So if we were to upscale this to an actual construction project, which they'll be probably using tons of cost aggregate, you can actually save, for example, for every 1 ton of cost aggregate, you can actually save 100 kilograms of, you'll only be using 100 recycled cost aggregates, 100 kg of recycled cost aggregates. And the cost aggregates that you save can actually be used for non-load bearing structures, for example, like your pavements and roadside curbs. Yeah.
So this sounds like a lot of materials which has been saved. So we are just wondering if there are any other companies which are interested in this project.
Yes. PSCA strongly encourage consultants and builders in the construction industry to use green concrete to construct non-load structural elements, such as non-load bearing partition concrete walls, roadside curbs, footpaths, cycling tracks, and park connector network, walkway slabs. For example, Samo Eco Green building located at Kranji is the first building in the Asia Pacific region to use up to 100% RCA for its structural concrete. The whole building was installed many instrumentation to monitor its structural strength performance compared to regular concrete. This testified that green concrete are just as sound as conventional building materials. Yep.
We can now look forward to more green buildings in future. Thank you, Team 3, Green Construction Materials, for the presentations and reply.
Thank you.
Thank you.
Yes, now it's time for the quiz in the Zoom poll. There are 3 questions related to the projects presented earlier, and prizes will be given to the first 2 submissions with the correct answers. Good luck! As you work on the questions, the 4th project will be presented. It is titled Design and Build an Iron-type Battery. The student presenters are Jerome Chua Jia Rong and Sean Kwa Jia Bun. Now, let's watch the project video.
Due to global warming, sustainable energy has become of crucial demand. However, current sustainable energy options such as solar and wind are intermittent. This gives rise to the need for a backup energy storage system. The energy storage system is currently dominated by lithium-ion batteries. Although they do produce a lot of electricity, they have major flaws such as being expensive and toxic. A possible solution is to use an iron-type battery. Iron is both cheap and environmentally friendly. However, it doesn't produce as much electricity. Our project aims to improve the iron battery such that it's not only cheap and environmentally friendly, but also produces sufficient electricity to meet society's demand. The iron battery consists of 2 major components, the iron 2 chloride and the iron 3 chloride. For this experiment, fresh iron is obtained. However, iron can be easily scavenged from waste for reuse. On the left, we have the iron 2 chloride, while on the right, we have our iron 3 chloride. Once these 2 solutions are completed, they'll be placed in a cell such that redox reaction can happen, and electricity will be produced.
We use Autodesk Fusion 360 for the designing of our battery. This software helps us to visualize our product for easier planning and to carry out our experiments. We use technologies such as 3D printing to create mold for our gasket and laser cutting to help us cut our acrylic casing design. We have combined our components of the battery and we are left with injecting our electrolyte solution into the cell, and we will proceed on with testing of our battery. Now we'll be verifying if our battery is working by inserting it into the multimeter. Throughout this journey, we have been through thick and thin, learning more about our battery technology, engineering design, and characterization techniques. We hope our project helps to influence other students out there to be more aware of the sustainable and environmental issues, creating an environment where more and more creative minds conduct projects similar as ours to help the environment.
That was an awesome video. So we are all curious about this new battery. Let me start off with the first question. Why do you guys choose iron?
In your everyday household, the most common type of battery you'll find is the lithium battery. From our research, we found that lithium is a very rare material. It is very expensive to obtain. In addition, it is also toxic, making it very difficult to throw in the landfill. When incinerated, lithium battery will release toxic gases to the environment. We chose iron as iron is a very abundant material. It is everywhere. It is commonly used in industries such as the construction, process, as well as the medical industries. It is also non-toxic, making it safe to throw in the landfill. This makes the batteries very environmentally friendly as compared to the lithium battery.
There are many materials available for making batteries. If iron is so good, why hasn't it been used in current batteries that we see in the market?
So I would like to answer that question. So iron is not a very reactive material as compared to lithium. So lithium is definitely one of the most dominant and efficient choice for energy storage systems. However, the world is facing problems such as climate change and environmental issues. So we need to find a greener solution and greener material such as iron for our battery to ensure that our battery is as comparable to lithium and as well as to make sure that it's environmentally friendly.
So with other materials which are available, do you consider any other sources besides iron?
As the world moves to a more sustainable mindset, battery manufacturers are looking for alternative sources of environmentally friendly batteries for energy storage. Before settling on iron, our group decided to look into other batteries such as the nickel battery and hydrogen battery. We found that nickel batteries were weaker than iron batteries. Iron batteries produce higher voltages as compared to the lithium counterpart. As for hydrogen batteries, they are expensive and complex to make. Yeah.
We always long for battery with long usage. So what improvement can you make to this battery that you have?
So I'd like to answer that question. An area of improvement that our team has discovered was the addition of carbon black. So carbon black is a conductive agent which helps to improve the ionic conductivity within the battery. So this would help to improve our overall reaction kinetics within the battery itself and the electricity generated.
I think our team...
And another area of improvement that our team has studied is the effect of the electrolyte solution exchange. So we added reservoirs and pumps to both sides of the electrode to create a flow battery. We hope by doing so, the performance of the battery can be improved as the electrolyte solutions are being exchanged in real time.
You must have done a lot of research when you're doing your project. So what are the skills you need to apply for your project work and the challenges that you have faced?
To make the battery, we needed skills such as battery chemistry, chemical lab skills, 3D printing, as well as laser cutting. For battery chemistry, we needed to know which combination of chemicals produce the best results. For us, iron 2 chloride and iron 3 chloride produce higher voltages as compared to the other combinations of material. Chemical lab skills were needed in order to make our prototypes accurate and reliable. We had to conduct multiple tests as well as see which data we needed to analyze in order to perfect our battery. 3D printing and laser cutting skills were also needed to make the gasket, to make the casing. Fusion 360, a program used by 3D modelers, are commonly we had to use it in order to design as well as construct the casing. Yeah.
How does this iron type battery compare to a normal battery?
So the iron battery is still currently in the infancy stage at this present stage. So the open cell voltage and as well as the current capacity of the iron battery is still lower than the typical lithium type batteries. But the potential is still there, and hence our project.
You mentioned that the iron battery is slightly weaker. So Can this kind of battery be used in an electrical car?
That is a tall order, but I agree that only when iron batteries can power electric car, then can the iron battery play a significant part in making the world a more environmentally friendly place. We are not there yet, and this is the goal of many researchers and engineers, inclusive of ourselves.
I'm sure we are all looking forward to a day where we can use an iron-type battery. So thank you, Team 4, Design and Build an Iron-type battery, for the presentation and replies.
The fifth project of the day is titled Hybrid Propulsion, Solar-Powered Boat. The student presenters are Joey So In Chi and Muhammad Haziq. Let us watch a video now.
Our project is a marine hybrid propulsion system which helps reduce carbon footprint by reducing pollution to the environment and improves energy efficiency. The aim of our project is to design and build a boat that uses a hybrid propulsion system which will utilize solar energy as its main power source and have a battery as its energy reservoir. The electric power generator is applied on the main electrical motor which will propel our boat. We also have a diesel generator as backup. The maritime industry alone accounts for 2 to 3% of carbon dioxide emissions globally. Also, the sulfur oxide produced as a result of combustion on board ships contributes to acid rain, which may in turn harm marine life, forests, and increase the ocean acidity. In order to reduce these air pollutants, we need to reduce our reliance on fossil fuel. Recently, the maritime industry started looking for greener alternatives. The International Maritime Organization even set a new regulation where ships can only use fuel which are 0.5% sulfur or less, unless they have a scrubber system.
Our plan for a hybrid propulsion system would be to use the sun as our main source of energy. So we actually planned on how we were going to connect a solar panel to the outboard motor of our boat using a maximum power point tracking. By planning the resources we were going to need, together, with the short period of time, we managed to assemble the different parts of the boat. Initially, we planned on using 2 solar panels. However, we only managed to use 1 as it affected the stability of our boat. Our limited budget, bad weather, and sea conditions posed as a challenge to us because we were unable to afford the watertight electrical connections and parts needed for our boat. Therefore, we had to make use of whatever we have to ensure our system functioned properly. This project will definitely benefit the maritime industry, ship companies, and the environment. With the use of this system, there will also be lower operational costs, maintenance costs, and reduced noise levels on board ships.
All in all, we managed to overcome the challenges we faced, and we are really happy with the result of our project. With the maritime industry taking a step into greener alternatives, we hope that this hybrid propulsion concept will be widely used in the future as another green energy contributor.
We heard about solar car. We are all excited to see a solar boat. So may I ask the team the questions? What is the aim of the project?
Firstly, thank you for the question. The aim of our project is to build and design a boat that utilizes an emission-free and green energy propulsion system. As you all know, fossil fuel consumption is the main source of air pollution by ships in the marine industry. The pollutants created are carbon dioxide and sulfur oxide. These harmful gases contribute to global warming and lead to the increase in sea level and temperature of the environment. Just like other industries, the maritime industry is also under great pressure to reduce their impact on the environment. Most of the hybrid propulsion systems currently used on board cargo ships right now are still in their trial stages and are not widely used as of now. So we hope to surface our idea to the maritime industry that solar power is a viable and sound option for shipping.
It's quite interesting that solar power is being used for a boat. So can you briefly explain the working principle of your propulsion system?
Okay, thank you for asking. So how our system works is we will harvest energy from the sun with the help of solar panels. And that will be converted into electrical energy, and which is used to power up the motor and spin the propeller. That gives us our propulsion. And any excess energy generated would be stored in our batteries.
Well, we can see solar power being used in lighting and so forth. So why was solar powered propulsion selected?
Currently, the most promising trends are wind, solar, tidal, and nuclear power. But we chose to do solar power because to build a solar power system is much cheaper as compared to other green energy options. And because Singapore is located near the equator, this makes solar energy more abundant in our country, especially in the open sea. So during the power generation process, there will be no form of waste produced that can be harmful to the marine environment. This system is definitely 100% emission-free. So this is why my group and I have decided that solar power is the best option for us.
Great. So what are some of the technical challenges that you have faced during your project?
That's an interesting question. The main technical challenges we faced were the efficiency of the solar panel, the battery storage capacity, the boat stability, and the weather. So firstly, we had a difficult time trying to find a solar panel that had an efficiency that was suitable for our system, because most of the solar panels available in the market right now have a panel efficiency of 18 to 22%. Instead, we used a solar panel that had a large horizontal surface to accommodate our system. Secondly, another challenge was the battery storage capacity. So currently, the batteries available also have very low storage capacity. Currently, the battery we used was a 200 ampere hour lead acid battery, which weighs more than 30 kilograms. As a result of that, we had to reduce the number of people on board because the weight of the battery itself reduced the buoyancy of the boat. Thirdly, boat stability was also another challenge for us. In order for a boat to float steadily, it requires sufficient buoyancy and stability. Because of the size and weight of the solar panels and the battery, we had to carefully consider the position of each of the equipment, and we also had to use our ship stability calculation. So we also had to ensure that all of our equipment and structure were properly tied down to withstand the rolling and the pitching of the boat. So last but not least, the system was built to be suitable for the marine environment. So the weather and the condition of the waves are also some of the major factors we take into consideration during the design and construction process of our boat. To ensure everything on board works perfectly, we actually sealed all the electrical connections and electrical panels with plastic bags. So overall, the efficiency of the solar panel, the battery storage capacity, the boat stability, and the weather are the four main technical challenges my group and I faced during our project.
The team must have gained many experiences while overcoming all the challenges. So how is the project benefiting the industries, the shipping industry in particular?
So we envision that this system will be commercialized in the future, and it's an option to reduce air pollutants emitted, lower maintenance costs due to lesser moving parts, lower operational costs due to lower fuel consumption, and lastly, to reduce noise pollution on board ships and to the surroundings.
What are the technical skills needed to do this project?
So the technical skills that we faced was mostly what we learned in our marine engineering. So like for example, for the stability calculations, we
referred back to our naval architecture. So for our calculating the center of gravity and the center of buoyancy. So we refer back to our notes and then compared to the data that we have on our the boat. Then for the electrical systems, we look back to our electronics and our marine power plant. So we slowly analyze the system and determine how much each system needs, like for example, how much power and the required circuit breakers that we need. And then lastly, for building the entire ship itself, we had hands-on experience during our marine workshop practice, so such as hacksawing and assembling the parts itself.
So can this boat be fully solar powered?
Currently, due to the low efficiency of the solar panels, this will only meet the basic auxiliary power consumption during the day and will only enable the boat to move at a very low speed. Furthermore, we are unable to obtain solar energy at night. So this is the reason why we require a fossil fuel plant as a backup. Joey, would you like to elaborate?
So for fully functional solar boat that will meet the industrial requirements, the solar panel needs to be at least 60% efficiency, to be 60% efficient, and the battery capacity to be at least 3 times in order to accommodate enough power for situations like when there is no sun.
We sure hope one day we can cruise in a solar boat. Thank you, Team 5, Hybrid Propulsion Solar Powered Boat, for the presentations and replies.
Now, the last project of the day is titled Smart Rehabilitation for the Elderly. The student presenters are Kang Yi-Ting and Ling Kai-Sing. Now let's watch the project video.
Singapore has one of the most rapidly aging populations in the world. It is projected that by 2030, some 25% of the population here will be aged 65 and above compared to the current 16%. One of the most common problems faced by the elderly is their daily struggle with mobility and their daily tasks, particularly if they have had a stroke or have been diagnosed with dementia. It is critical for such elderly to undergo a rehabilitation program after their discharge from hospital to restore their functionality, increase their mobility, and make them more independent. For such elderly, our project aims to facilitate their undergoing rehabilitation at their homes or a senior activity center where our smart rehabilitation system would be installed to provide them with an integrated and comprehensive exercise and assessment platform. This consists of a smart therapeutic pet robot called Sparkle and a smart activity game called MTech.
Sparkle is a therapeutic robotic pet for the elderly to reduce the progression of their dementia. Sparkle's face has a built-in camera which allows it to greet users uniquely and gives personalized responses using facial recognition. Sparkle can provide positive and negative reinforcements according to the patient's progress in their rehabilitation. Peripheral gadgets in the form of mini games like game boxes, smart gloves, and smart dumbbells facilitate the rehabilitation session. Its data is uploaded to Google Sheets automatically and is used to track the progress of the rehab sessions. These sessions can be conducted by therapists online during this pandemic.
MTech, which stands for Music Technology Activity Games, is designed to help patients with upper rehabilitation. It consists of 2 games, Speedy Car and Fighter Plane. The games are controlled by a container hand motion tracking system called Blip. The Blip controller has 3 infrared LED sensors and 2 cameras that capture the user hand motion and map out geometry and coordinates through Unity software. MTech is a non-contact game which prevents cross-contamination during this pandemic and can be played at home. The patient data is stored in the Data Cloud for therapist reference, allowing for easy and safe monitoring.
With smart solutions like Sparkle and MTech, we can reduce the load of healthcare and daycare personnel while creatively engaging the patients. This project offers a smart remote home care rehab model during this pandemic where education, work, and COVID recovery can be done at home.
It's good to see projects being built for rehabilitation. So thinking back, what inspired you to embark on this project?
Thank you so much for that question. Yeah, I think as we look back at the video, most of the content was regarding objective facts about the project. Yeah, so I hope that today, Kai-Sing and I will be able to present to you a bit more personal and first-hand experience about our internship in this project. Yeah, so I think to first answer the question, what inspired me? Personally, I really feel that, being able to see elderly enjoy the golden years of their life really brings a smile to my face. And what better way to enjoy your life, regardless of age, than to live a healthy and simple life, right? Yeah, so, and that is exactly the aim of this project, to rehab and to restore and maintain the function of the elderly. Yeah, and this project has two aspects, as you have seen in the video just now. One is MTech, which stands for Music Technology Activity Game, where it focuses on the upper limb rehab of the elderly, namely the wrist, elbow motion, and shoulder motion. And also, we also have this robotic pet, the cute one, called Sparkle, yeah, which is this inanimate form of companionship to the elderly. Because we noticed and we read some research papers talking about how loneliness is actually a prevalent issue among the elderly. Yeah, and hopefully, both MTech and Sparkle collectively will be able to restore the function and maintain the function of the elderly, and hopefully able to give them a better enjoying quality golden years of their life. Yeah.
Very happy to hear that the team is taking care of the elderly. Is there any other category of patients that you can use this setup?
Yes. Another potential target audience for our project is children under 13 years old. MTech can be used by pediatric patients with the chronic upper limb impairments or injuries. Our MTech actually focusing on developing the psychomotor skill to restore the function of the upper limb without the using of the free weights. Although the limb motion controller have some limited detectable radius, so it's more suitable for children to using it. Seeing the MTech is a game, so it provides a more enjoyable experience for the children while doing upper limb rehabilitation.
Yeah, and that's for MTech. Thank you, Kai-Sing. As for Sparkle, as you have seen, it is this cute dog, and it is, as I mentioned just now, this form of inanimate companionship. And I think that one other target audience, children, specifically maybe children with autism, will be another prime target audience, because we notice that children with autism and elderly with dementia have similar behavior in a sense that they're simple and innocent. Yeah, and also we notice that children with autism may struggle with social interaction, so things like eye contact or like picking up social cues and all these things. Yeah, so perhaps having an inanimate form, non-human form of companion will be able to encourage these kind of social interactions, which hopefully will help them better interact with people in the long run. Yeah, so collectively, once again, we think that both MTech and Sparkle will be able to help not just the elderly as our primary target audience, but also maybe the children as our secondary target audience. But of course, everybody is welcome to give it a try.
So this project seems to be quite complex with a two-in-one. So Yawan, just wondering what technology is used in this project?
Thank you for your question. Our project has many parts. For the MTech, we're using the lead motion controller and the Unity C# programming. Well, the electronic gadgets for the Sparkle, like Gamebox and the Smart Dumbbell, are coded with C++ and Python, using the software like Arduino. For the body of the robot dogs, it's 3D printed, and the legs are built with motors and able to eat together. After that, we cover the body of the robot dogs with the fur to make it more visually appealing. Yes.
You mentioned there are many parts to build the project. What was the most difficult part of the project?
The most difficult part of our project actually is we need to learn everything from scratch. Many things of the project are new to us, so we need to put in pretty much effort to learn it on our own. Although our senior did a good job to handing it to us, but after it's difficult on our own. Yeah.
You must have learned a lot from your experience. So what would you say to the secondary school students while watching this, considering engineering as their future course or profession?
Yeah, thanks for that question. I think knowing this is a webinar that targets secondary school students who may be choosing their future course, I think this is a very relevant question. Personally, for myself, I feel that engineering as a profession is an extremely meaningful and exciting course. Why? Because we're able to use innovation, we're able to create things with our hands. And seeing the work of our hands bring impact and value to society is something very satisfying and fulfilling for myself. Yeah. And I think to see that it brings benefit to others, to see them enjoy our product, and I think previous batches have even brought the sparkle to elder homes as well, and really see them enjoy. Yeah. So apart from that, we work in teams. So there's this sense of teamwork, and after we accomplish everything, there's this not only sense of satisfaction, but there's also this sense of camaraderie between teammates. Yeah, which is something that I really look forward to, and it really just makes that day and night difference to tide through another tough setback and disappointment. Yeah, so if I may just share another experience during internship right now, which both Kai Sing and I and my other teammates who are watching live right now are going through. Yeah, shout out to y'all. Thank you for this amazing experience. And I think, you really make a huge difference. So, yeah, Amira and Gina, you're watching this. Shout out to you. Yeah, thank you for that. And I think one last note for people, for secondary students like you who may be considering or maybe not so sure about what profession or course or career to choose. I think it's okay. It's perfectly fine. Everybody is still figuring out, what your interests are. I only encourage you to go give a bit deeper thought, maybe consult other people. And then I think the last thing would be, don't be afraid to try. Yeah.
That's a very good comment, encouraging the young students to join the course. Now, back to the project. I haven't seen that your project is working very well in the lab, and the team has spent a lot of time developing this project. Will this project be used in the hospital?
Yes. Our earlier version of the games is tested in a local hospital, and now we are waiting for the feedback.
Okay, so just now in the video, we saw a very cute dog. So besides a pet dog, is there any other pets which are available?
Yeah, actually for our project, this robot pet, right? You notice it's not just, it's phrased as robot pet because it's just a skeleton, and whatever we put on top, it can be any other animal. So as of now, we have a pet dog, but actually we have been working on other things like pet cat, and anything that we can put a fur on that resembles the shape of a four-legged animal. Yeah, and I think if we compare it to the industry, right, there are other pets like Paro, which is this robot seal that is just a companion robot pet that responds to the touch, which I think our project is able to do that as well. Yeah, so it involves theories like capacitive touch. When you touch a certain area, the electrical signals are sent to the microcontroller, and then the dog responds. Yeah, and I think each project in the market has a different focus. So, for example, Paro, this pet seal, is more for companionship. Yeah, but our project not only is able to provide companionship, but there's also this idea of therapy in the elderly. Yeah, so things like combating the onset of dementia and the upper limb rehabilitation of the elderly. Yep.
While building the project, we heard that you also use a 3D printer. How you find 3D printing?
I think 3D printing is an integral part of our project because most of the designs may come in very odd shapes. Yeah, and I think it's also a very good opportunity to hone our creativity, to come up with weird shapes that ultimately is able to bring a solution, a fitting solution to our design. And yeah, we have actually one student in my team who is specially does the 3D modeling. Yeah, so I think our group owes it a lot to her. Yeah, and a lot of the times 3D modeling, yes, it is a time-consuming process. So most of the times, if I could
like maybe in a 100% distribution, maybe 20% of the time will be used for designing, and then the remaining 80% is just waiting for it to print finish. Yeah, so in the meantime, we can just use the time to like have team discussions, or just see whether there are any hiccups in the printing, or just plan ahead of the project. Yeah.
Thank you.
Thank you. It's good to see 3D printing being used in your project. So thank you, Team 6, Smart Rehabilitation for the Elderly, for the presentation and replies.
Thank you all, the presenters, for the wonderful sharing. Thank you all, members of the audience, for being part of this event and your support for the event.
Now, it's time for the second quiz in the Zoom poll. There are 3 questions related to the projects presented earlier, and prizes will be posted to the first 2 submissions with the correct answers. And all winners will be notified by email. So all the best.
We have come to the end of the live webinar sessions. We will appreciate if you could provide your feedback by scanning the QR code in the next slide. Please note that there will be one more SP Engineering Show live webinar tomorrow at 3:30 p.m., which will showcase another 5 exciting projects. Have a nice day, and we see you again tomorrow at 3:30 for the second session of Singapore Polytechnic Engineering Showcase Webinar 2022.
Goodbye.